Hello children, we have come to the last part of rational numbers. I hope you all have done all the sums which were in video 1, 2 and 3. So this is the last portion of the chapter rational numbers. Let's continue with some more examples, and as usual these are your classwork sums while the assignments are your homework sums. Let's start with the first sum of this video. It's question number 101 from your book Exemplar. It says, insert three rational numbers between -half and 1/5. That's the first part, -half and 1/5. Now listen to the rules, children. Since the denominators are different, we have to make it same. And what's the method? Yes, the LCM method. So the LCM of 2 and 5 is 10. And next what do? We have to convert each of these given rational numbers into rational numbers with the same denominator, and that is 10. So -1/2, if I want to convert to a rational number with denominator 10, it's -5/10. Whereas 1/5 is equal to 2/10. So we now have the rational numbers -5/10 and 2/10. Now just look here. The denominators are same. The difference lies only in the numerators. It's -5 in one and 2 in the other. So if I want to insert three rational numbers between them, so that means I need to choose integers which lie between -5 and 2. So my answer can be any of the following, that is -4/10, -3/10, -2/10, -1/10, 0/10 and 1/10. So these are the numbers between -5/10 and 2/10. So any three from these can be your answer. Part 2, it's again inserting three rational numbers between 0 and -10. Now 0 means 0/1, -10 is -10/1. So the denominators are already same, but the numerators are different. Obviously it's 0 in one and -10 in the other. So any three integers lying between 0 and -10 will be your answer over here. So the three rational numbers are any from -1/1, -2/1, -3/1 till -9/1. Any of the numbers, any three numbers can be taken from these given numbers. Question number 102. It says put a tick mark wherever applicable. Now we have a grid, a table over here where a few numbers are given on the extreme left hand side and the options are there. Now the options are like whether a given rational number, whether a given number I should say, is a natural number or a whole number or an integer or a fraction or a rational number. Now like it may be that you have to give tick marks in more than one box. It can be. So let's see one by one. -114. Is it a natural number? No, because when we count, we do not count by saying -114, right? So it's not a natural number. It's not a counting number. It is a whole number? No, because whole number starts from 0 towards the positive side, not the negative side. It's an integer? Yes. because integers are minus, 0 and positive numbers. So it's an integer. Is it a fraction? No, because fraction cannot be negative. Is it a rational number? Yes, of course, because it can be written as minus 114 by 1. So it's an integer as well as a rational number. Part B, 19 by 27. It's not a natural number, it's not a whole number, it's not an integer, it is a fraction as well as a rational number. 623 by 1. Yes, it is a natural number or a counting number. It is a whole number as well. It is an integer also. It is a fraction as well as it is also a rational number. Part D, minus 19 3 by 4. Obviously it's not a natural number, it's not a whole number, it's not an integer, it's not a fraction even, but if you convert to a p by q form, we definitely get a rational number. So it is a rational number. 73 by 71. It's not a natural number, nor a whole number, not an integer. Yes, it is a fraction. It is also a rational number because it is in the p by q form. 0. Obviously 0 is a whole number. It's an integer. It is a fraction also because it's 0 by 1. It is a rational number also. So I think children, by doing this particular sum, you get an idea of what the differences are between natural numbers, whole numbers, integers, fractions and rational numbers. Question number 103. A and B are two different numbers taken from the numbers 1 to 50. Now the question is, what is the largest value that A minus B upon A plus B can have, and what is the largest value that A plus B upon A minus B can have? Now A minus B can be largest only if A is 50 and B is 1. So putting the values, it's 50 minus 1, 49 upon 50 plus 1, 51. Again in the second part, the numerator will be largest if A is 50 and B is 49. So A plus B is 99 and A minus B is 1. So the value is 99. Now we have a few assignments. It's question number 99. From a rope 68 meter long, pieces of equal size are cut. If the length of one piece is 4/1/4 meter, find the number of such pieces. Now actually it's a normal statement sum, problem sum, where the entire length of rope is given and the size of each piece is given. So how many pieces? Obviously it's a division sum, where 68 will have to be divided by 4/1/4. So I've just given a clue, a hint to the sum. Please do it on your own with proper statements. Question number 100. If 12 shirts of equal size can be prepared from 27 meter cloth, what is the length of cloth required for each shirt? So again it's a similar type of sum where division has to be done. Question number 105. A body floats 2/9 of its volume above the surface. Means whatever the volume is, 2/9 of it is above. So that means the rest is below. Now the question is, what is the ratio of the body submerged volume? Means the submerged portion is to the exposed volume. These two ratios we need to find out. Ratio of the submerged volume to the exposed volume, and then rewrite your answer as a rational number. Okay, so I've just given you a hint. If 2/9 is above, that means the remainder 7/9 is below. Now I hope you can do the rest of the sum. Now since we have come to the end of the chapter, you have to do the mind mapping, and it's again your classwork. So I have shown the mind mapping in this manner. You can always change it in your own way. Okay, so it's just a recap of the entire chapter. See, in the center I have written rational numbers, which is in the form of p by q, where q is not equal to 0. Then we have learned that all integers and fractions are rational numbers. Rational numbers can be positive, 0 or negative. There are unlimited rational numbers between two given rational numbers. Then we have learned about the standard form of rational number, means denominator should not be negative and the entire number should be in its lowest form. And then we have come to the distributive law of multiplication, the additive and multiplicative inverse we have learned. So this is also applicable in rational numbers. And commutative and associative property, this you have learned when you did integers. It's also applicable in rational numbers. Means two rational numbers, the sum of two rational numbers is same even if you change their position. Means a plus b is same as b plus a. So the properties are all same in whatever you have learned. In case of integers, it's same and applicable to rational numbers also. So this is how you are going to draw the mind mapping, make it colorful, make it neat. Okay, so after a few days you will see the solutions of all the assignments of these rational numbers, all these 4 videos, the 4 assignments. It will be uploaded so you can do your own correction, and you'll also get another assignment which you have to mail to us. There is a feedback on rational numbers. So thank you children, and have a nice day.